There's a very strange debate going on between climate scientists and economists about the cost of climate change. Climate scientists say things like,
we will see tipping points, we will see massive heat wave, we will see crop failure.
But economic research has predicted a bizarrely different future.
What these papers do is lead you to this interesting conclusion that, well, maybe climate change isn't the global catastrophe that we might think it's going to be.
Scientists say, no, this is going to be really, really bad. And economists say, meh.
And this debate really matters because it determines how quickly we get off of fossil fuels. Going too fast, some say, would be too expensive and disruptive. Too slow, and the damage could be catastrophic, even irreversible. But new research sheds light on why this debate exists and may finally settle it. Using a new modeling method, scientists have put a price tag on how much climate change will cost each person on Earth, and it's not cheap. So in this episode, we'll find out how much climate change will cost us, and we see if we can find the sweet spot, or the so-called optimal amount of warming that creates the least damage possible. Economic models take climate projections and use them to estimate future economic growth. But there's a problem.
Previous papers that do this type of modeling, they predict very mild to moderate impacts from even severe future climate change on the global economy.
And this matters because economic models play a big role in shaping climate policy, including determining the price of carbon, which is essentially an estimate of the future cost of emitting an additional ton of CO2 today. And getting that number right is crucial as we transition away from fossil fuels.
What you're essentially doing is weighing up the short-term costs of abating greenhouse gas emissions and balancing that with the long-term benefits of avoiding future climate change.
These older models only predict about a negative 10 to 12% drop in GDP per capita by 2100.
That is a meaningful decrease, but in 2100, it's actually an extremely minor impact. When you consider the technological growth, productivity improvements that is going to happen to the world between now and 2100.
But if economists don't predict seriously negative economic outcomes from even severe warming, then why would we spend trillions to get off of fossil fuels? Because what if economists are right and climate change isn't the global catastrophe we've been expecting? Well, this is confusing because if you're familiar with weather, you know that climate scientists are singing a completely different tune. We're currently on track to hit 2.7 degrees of warming by the end of the century, which again, if you've been watching this show, you know is bad news. 2.7 degrees is far off from the global commitments like the Paris Agreement, which aims to keep warming to 1.5 or at worst 2 degrees Celsius. And this agreement was established to avoid disastrous climate impacts like sea level rise and tipping points. A tipping point describes a point of no return for a climate system. They are thresholds that, once crossed, will cause large-scale and potentially irreversible damage with massive consequences for humanity.
It really looks like a different world if we cross these climate tipping points. We're talking about the major ice sheets on Antarctica and Greenland that together could give us 10 meters of sea level rise. We're talking about major ocean currents that set the pattern of climate for all of us. And then the frozen permafrost of the high Arctic, which, as it thaws, it can release twice as much carbon as is currently in the atmosphere. And then there's bits of the living biosphere.
Like the Amazon rainforest, the most biodiverse region on Earth, which stores so much carbon that if it collapses, it can release enough emissions to make staying below 1.5 degrees of warming virtually impossible. Or coral reefs, which support the livelihoods and food security of about 1 billion people. But they're already on the brink of collapse. And at 2.7 degrees, many of these tipping points would be crossed. Our planet would be a completely different place, one that's far less hospitable. So why is there such a discrepancy between economic and climate science recommendations? Well, according to Tim, the previous economic models weren't looking at the full picture. These previous studies didn't look at global weather impacts, which is critical since both our climate and economies operate on a global scale.
What matters for future climate change is not how each individual country's weather will change, but how the global weather is going to change and how countries are going to experience bad weather events simultaneously. The fundamental problem was this. What they're estimating at the end of the day is the impact that local weather shocks or local weather conditions in a particular country has on the economic growth of that country. What you're implicitly saying is that what matters to the United States and its economic growth in the future under climate change depends entirely on how climate change will affect the weather of the United States.
But when you isolate one country, you don't consider how interconnected our economies are.
International trade is fundamental to the growth of pretty much all economies in the world today. What happens on the other side of the world can actually have a very dramatic impact on your country.
So if there is a heat wave in Ukraine or a drought and there's a crop failure, what does that do to the rest of Europe, which relies on that kind of wheat for getting cheap groceries?
So we won't be able to rely on these trade relationships that have allowed economies across the world to flourish. And as weather across the board gets worse, crops fail and trade suffers.
You can no longer assume that you can rely on these trade relationships to get you through bad harvests, to get you through severe prolonged droughts and other problems.
When you think about it this way, why would you isolate individual countries in a model that looks at future GDP on a global scale? Which is where Tim's new research comes in. He looked at global rather than local weather in his model. And this quadrupled future GDP losses from climate impacts because in future high warming scenarios, countries are going to be experiencing extreme weather at the same time. And those impacts will reverberate across borders. So what happens when you factor in that real world complexity? Tim's model shows that under a high emission scenario, by the end of the century, global GDP wouldn't shrink by 10 to 12%, but by 40%. So about 4 times more than we've been accounting for. But if we're all going to be an average of 40% poorer by 2100 under a severe warming scenario, it seems like we should transition to renewables as quickly as possible. Let's imagine an extreme hypothetical for a moment. Let's say we pulled the plug on fossil fuels really quickly, like overnight. Well, it wouldn't be pretty. Vital services like hospitals, water treatment, refrigeration, and communications would immediately begin to fail across large parts of the world. Transportation would grind to a halt, and global supply chains would collapse, triggering widespread food shortages within weeks. Economic systems would unravel, and billions of people could be at risk due to hunger, thirst, and lack of medical care. Now, this is a wild hypothetical, but it helps to illustrate just how deep our reliance on fossil fuel runs and how transitioning to a cleaner economy will fundamentally take some time. It also hints at this idea of an ideal or Goldilocks path to decarbonization. Not too fast, not too slow. Because at the other extreme, moving too slowly could be even more damaging in the long run than an abrupt shutdown. And that feels like the far more likely scenario. Back in 2016, climate modelers created 5 different future worlds called the Shared Socioeconomic Pathways, or SSPs. The models take into account factors like population, GDP growth, technological developments, energy supply and demand, and land use. Today, we seem to be on an SSP2 pathway. But how does recent climate policy, or lack thereof, affect future warming?
It's certainly possible for us to end up in a world that's worse than current policies. And one of those that we worry a lot about is something called SSP3. And SSP3 is a world where resurgent nationalism, isolationism, regional conflict leads to countries pulling in on themselves, prioritizing domestic energy resources like fossil fuels, having less innovation, less trade, and that ultimately could lead to a world of significantly higher warming, 3 degrees, 3.5 degrees C by the end of the century.
According to Zeke, we aren't quite headed down this path yet, but we are moving in this direction. The fear is if countries subsidize fossil fuels and prohibit clean energy technologies, then this is a viable future.
I think it's important to realize that we shouldn't take current policies as set in stone. It's certainly possible for us to end up in a worse future if the world backslides on the progress we've made so far.
So if quitting fossil fuels overnight would have disastrous consequences, and doing too little would be potentially even more disastrous and expensive, is there an optimal path to decarbonization? A popular economic model predicts 2.7 degrees by 2100 to be the optimal amount of warming. But Tim found a very different number.
When you improve the models by allowing global weather to also affect local economic growth, it now suggests that welfare optimal decarbonization speed and strength is to allow only 1.7 degrees of warming from now until the end of the century, which is highly consistent with the ambitions of the Paris agreements.
So 1.7 by 2100 is the Goldilocks number. That is extremely fast. We don't have any time to waste.
The amount of effort required to stay under 1.7, I imagine, would be decarbonizing by 2050.
It's so fast, it feels completely impossible when you look at what's happening in the US and around the world. We already passed 1.5 degrees in 2024, and climate policy in the US is not helping, especially when it comes to possibly the most powerful climate policy tool, carbon pricing.
We do not have a federal carbon price, and every other developed country has some kind of federal carbon price. The basic idea is that you want to estimate what putting an additional ton of carbon into the atmosphere, what cost that imposes on the whole world. Like, how many more wildfires are you going to get? How many more hurricanes are you going to get? How many more heat waves are you going to get? And what are the economic damages associated with those?
Can we value in today's dollars the kind of economic damage that we impose on ourselves in the long run from emitting every extra ton of carbon today?
And carbon pricing isn't remotely controversial, but the US is incredibly unique in the fact that it doesn't have a federal carbon price. And Catherine's kind of got a hot take on this.
I personally think that with the US very obviously off the leadership stage in terms of climate policy, this provides an opportunity for other countries to make progress on some kind of agreement.
And other countries are really stepping up.
If you look at the amount of money that's been spent globally on climate mitigation and on clean energy technologies, I don't think many people realize just how quickly it's grown. So if we look back in 2016, the world spent about $500 billion on clean energy technologies. This last year in 2024, we spent $2.1 trillion globally with a T. That's a big number.
And China alone makes up a little less than half of that investment.
They're investing in the 21st century economy, which is going to be a clean economy, or at least a cleaner economy. If there are any spillover benefits, the Chinese economy is going to benefit more from those than the US economy will.
The US is actually the #1 exporter of gas and the second overall for fossil fuel exports. And our exports have been growing. And part of that comes back to carbon pricing.
Take the set of G20 countries, so it's like the 20 biggest economies in the world. 3 of those countries in the G20 do not have a carbon price: the US, Russia, and Saudi Arabia. So it kind of makes us seem like a petrostate.
As pressure to transition to clean energy grows, it seems like we might be beginning to get left behind. But we aren't the only country that's dragging our feet in this transition.
The US is like 12% of emissions. We really need the other 88% to get on board, or, to step up themselves and drag us along eventually.
In many ways, the global clean energy transition is inevitable, even as the US backtracks on renewable energy policies. The reason is simple. Clean energy is often cheaper, and as the climate warms, extreme weather will intensify and energy demand will rise, making the shift to renewables and the push to cut greenhouse gas emissions not just appealing, but essential. But I'd love to hear from you. Are you still optimistic about the clean energy transition and our ability to avoid the worst impacts from climate change? Let us know in the comments, and see you next time on Weathered.